When we last left off and things were really cooking, one of the things I had you do was to find the mode. And I know there were some questions, some concerns. Some folks got it. Did anybody get a mode temperature for me?
Ours came up with a mode temperature.
What was it?
I'd have to run it again to figure it out. I
No.
can't remember.
Did you also do the average?
We didn't get time to do that, no.
All right. I didn't know if anybody. Um, okay, I got it, Dev.
We got like 67 for the mode.
67 for the mode. Good. I'm glad you didn't say 67.2 or something like that. But that's something I didn't see anybody post what they actually got. Oh, it's working, but making sure, I don't know if everybody had the exact same data file. Is that something that could possibly come into play? I mean, we could have some differences with that. The mode is 60. Was that a meow? No.
I think me and Brady got the same values. We were using the same data set.
All right, hold on. I'll yell at my dogs. Let me mute. I'm back. That darn leaf blew down the street right in front of the house, and they attacked it. All right, so mode of 67. Did anybody else get a mode of 67 or something like that?
We got 96.
For the mode.
Yes, sir.
Interesting. Did anybody get an average? Average should have been easier. Should have felt like you accomplished something quick with the average.
62.49 something.
62.49 for the average temperature in Harrisburg, Pennsylvania. 30 degrees higher is 90, 30 degrees lower is 30. I might be okay with that. It's interesting, the mode for last year was 96. And as a lot of you know about mean, median, mode, you know, this number could be all over the place, really. So I wanted to do some thinking before we move on with chapter 10, but how did you come up with the mode? Because I know y'all did a hell of a job typing. I don't know if any of you wrote things up, but you have this list of numbers, and what's the math behind coming up with the mode? Well, I'm thinking that it's the one that occurs the most often. So I might, you know, I might have I need to know what the number is, num mode, and mode frequency. Like, what is it and how often did it appear? Okay, so I'm going to start with 66, and I'm going to say, okay, my num mode, I'm going to start with 66. I'm going to go through the rest of the list and count 66, and it looks like my mode frequency is 3. Sound good?
Yes.
Okay. So now I think what I may have done, and again, there are probably 20 different ways to do this. I may have moved to the next number, 44, go through and count how many 44s there are. I see 2 of them. Is that greater than mode frequency? No. So I don't change my num mode and I don't change my mode frequency. Go to the next number, 21. How many 21s going through the rest of the list? There's only 1. It's not greater than or equal to mode frequency. So I think I may have grunted it out. I know some people were sorting and then counting runs. I know there were a lot of crazy ideas, and that's okay. But at the same time, if the surgery is over and the patient didn't live, but you did some really neat stitch work, but the patient still died, it doesn't do any good. So one of the things you need to do is make sure that you actually get it if nothing comes early on. All right, so I'm looking and I'm thinking that my num mode is probably an integer and my mode frequency is a 3, that kind of deal. But what if I would have gone through and said, Rutrow, George, what if they're now, and of course my test data, I now have another 44. And I go, okay, so I'm checking my second number. It's 44. And there's 3 of those, and it equals mode. Okay, it equals the mode frequency. So when I go through and count, it's either going to be less than, equal to, or greater than. If it's less than, I do nothing. If it's greater than, I switch it. If it's equal to, then I need to have a second number in here. So somebody, yeah. So one suggestion, and Matthew just put up, is I could store these in a vector. I'm okay with that. Is there another place I could have stored these? An array, maybe. The vector's good because I don't have to worry about losing memory. How about this for a suggestion? Could I have built an out string and alternate depending on if my new frequency was less than, greater than, or equal to? Matthew says you can clear the vector easily. Yeah, I can clear a string real easy. String equals double quote, double quote. So just some ideas, just some ideas. You know, down here, if it's greater than, I can just say string equals that new value. If it's equal to, I can say string equals string plus. Vector, I can push it because there's a function to push. I'm thinking that when it comes to displaying, Matthew keeps fighting me for vectors. And when it comes to displaying, what would be easier to display? A string or a vector? Let's see if Matthew puts string or vector down. Yeah, he's not going to say anything now. String,
I was
okay.
going to say string because
Yeah.
it's one line and that's it.
Yeah. So again, is there anything wrong with doing a vector? Nope, because you're thinking integers and you're going to push integers, and that's all fine. And at the same time, I could add to a string. So an easier way, I think, to go through, and one of the things right away was I need to do this. I'm on a time schedule. I needed to get it done. Okay. I have 2 variables, mode and mode frequency. And again, I started drawing all this. As I drew it, I knew there were 3 cases. If my mode frequency, my new frequency is less than mode frequency, I do nothing. I do nothing. Here, if it's greater than, I would update. Here, if it's equal, I'd add to num mode. If I hand you this, would you be able to code it really quick? Yeah, I think so. Okay. And a lot of you did the mode for me in CPS 121. You had a giant array of numbers. And I think if I recall, there were 3 numbers that matched the mode of 40, 41, and 42. Another thing you could have done is, could I have made an array of temperatures and maybe started at, realistically, where's the mode? Well, I don't know. We could have had a stretch of 5 days in a row that are -5, or a stretch of 101. So I'm thinking an array from -5 to 100, and then go through all of my days, 365 of them, and increment to each spot. So like if 67 was here and there's a bunch of 67s, that may end up as 5 of them. Okay, so by using a second array, I could have a count for each one of these. I could then go through and say, what's the highest number? 67's 5. If that's the highest number, then I would print 67. If there was another one that was 5 as well, like 78, I could go through and say, does it equal high? Does it equal high? Oh, this one equals high. Display 67. Oh, display 78. So by using a second array, I could accumulate all of these. I don't know, this might be a little slower, but it's a second idea of what to do. Create an array on the range of all possible temperatures. Not that hard to do a starting and an ending, but then go through the 365 and see what you come up with. Questions? Feeling better? Give me some thumbs up on your screens. I need reactions. A little less time, a little more reaction. Oh no, that's not the song. All right. Chapter 10. Let it come into focus. And here we go. Section 10.1. We're going to do some work with character testing. Now, going back to a parallel in your Java book, you know we're off chapters by one. This was chapter 9 back in your Java book. And it started out with character testing, and then it went into strings. But for us, our chapter 10 is going to be a little bit different in that we're going to look at strings plus some old string stuff. Okay. But to start with, we're going to take a look at some character testing. And in section 10.1, we got into a whole bunch of functions that can be found in CC type. So make sure you do pound include CC type. And every one of these functions returns a Boolean. And they're based on an argument of a character. Single quote, a single quote. If it is alpha, it would return a Boolean. Is it an alpha? Is it a number? Is it a digit? What's a digit?
0 through 9.
I'm sorry?
Digit would be 0 through 9.
Right. This isn't a number. This is AL number. Alphanumeric is what that's short for. That's kind of a good one. Alphanumeric to tuck away. Okay. Digit is lower. Now you notice all of these are similar because they start with the is. We know they're returning Boolean. But what's really odd is it's not written in camel case. I don't know why I have code there when I want camel case. In that, is lowercase, but the alpha doesn't start with a capital A. And the reason why is I have no idea. Okay, so you did code listings 10.1 and 10.2, and you were looking at some examples of how this is alpha and how is alnum and how digit and all of those work. If I take a quick look at code listing 10.2, some things to take a look at. I want to get ready, and this program is going to see if it's in the right format. And the format is LLL and then 4 NNNs, where the L's are letters and the N's are numbers. Well, that's kind of nice because my couts are going to tell me what to do to enter it to make sure, and I want to test to make sure it's right. Now, back in D2L, you now have a block of code you're probably going to start to put in here in the early parts. That is to eliminate the black screen of death, right? I gave you something from a student that they had that worked out nice. You can take it, play with it, do what you want with it. So when you turn your programs in, make sure you do that. Anna, I already graded yours. Don't worry about it. Thumbs up.
I saw, thank you.
Yep, yep. But from now on, Anna, make sure you do it.
Okay.
All right, good. All right, so I want to get a string in. I'm going to enter a line of code. I'm going to store it in customer and take a look at what customer is. Customer is a character array. Okay, it's not a string like we're familiar with. And the reason is we're going to go through and access each element one at a time in this character array. And character array is a term that's going to be with us today and next Thursday, because we have a test Tuesday, next Thursday and moving forth. So I want to read everything into this character array. And the reason is it's going to make it a little bit easier to go through one at a time and see if it's valid or not. So what do? I pass the character array in to a function. Okay, I'm bringing the size in. I'm going through and I'm using is alpha at customer num. That's my array of characters to find out. So I come in and, I'm setting it false and I return false, which means I found something bad and I'm out. Or if I start going through the second 4, not the first 3, but the second group of numbers, those 4, And if something bad, I get out. And then finally, I have a return of true if I don't get out in any of these. Now, traditionally, it's best to have just that one return. But in this case, it may actually be more efficient to get out while you can and save code. Then that comes into the whole, well, it's a for loop. Is that the way to really get out? Da, 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 da. It's okay. It's almost like a break. And some of you know I don't like breaks in for loops. Okay? But in this case, you see where it's going to become more efficient. Questions? Character case conversions. This time, instead of returning a Boolean, I'm actually going to return a character. For example, if I said turn to lower and I pass in uppercase, it's going to convert it into a lower. Now, what do you think is going on in this function? I'm bringing in an A, and tell me what you think is going on inside of to lower. If I asked you to change a character to a lowercase, I'll wait.
It looks to see what the letter is, and then it would change it to the lowercase for the ASCII.
Key word there is ASCII. ASCII, right? So I'm thinking that it's going to come in and it's going to, which one comes first, capital A or lowercase a? Because I know the difference is 32. I don't know if to add 32 to get the lowercase a or subtract 32.
Add.
Add 32? Okay, good. So are you telling me that in this function, all we're doing is adding 32?
Only if it's in an uppercase letter.
Yeah, so the first thing it might do is check the ASCII range to make sure, or to check to make sure it's between greater than or equal to capital A and less than or equal to capital Z kind of idea. And then if it is, it's gonna not have 26 if then else's or 26, it's just gonna use one line and it's gonna add 32 to it to get its new value and then return a new value. Otherwise, if it's not in that range, it would keep that value. So just some of the background of what actually is going on in some of these functions, things you could do. You know, I could actually check that. What's going on up in here? Is it alpha? It's probably checking to see if it's between little a to little z or big A to big Z. In fact, it may even use one of these to cut the time in half. Oh, 6 of one, half a dozen of another. Okay, so we're going to pause here after sections 10.1 and 10.2. And as you can see, I'm going to have you jump to page 607. And we're taking a look at number 3 and number 11. Number 3 is a word counter, right? A function that accepts what I want you, don't worry about this term C string right now, okay? It's going to take a look at a string, a character array that we're going to input, and I want you to tell me how many words there are. Well, how would you find out how many words there are? You would simply,
Whenever
for the
there's a
spaces.
spaces.
yeah, count the spaces and then
Add one.
add one, right? We're going to keep it nice and simple, but I want you to work with a character array to do the number of words. So that's number 3. The other one I want you to do is number 12, password verifier, okay? I want you to do, and it's going to sort of be like that one where we had to return the trues and falses, but I want you to ask for a password. It has to be at least 6 characters long. Should contain at least one upper, one lower, and it should have at least 1 digit in it by using trues and falses. So I'm going to put you into small groups. I'm going to give you about 25 minutes and then to do both of these, and then I'm going to bring everybody back. For the test on Tuesday, no notes, no books. If I had a lockdown browser, I'd lock it down, all of that. If you're coming to class and doing the assignments and everything, you should be good to go. Question that was just posted. Okay, again, you're doing word counter and you're doing password verifier. I'm going to pause. Seriously now,
with
recording's
them.
back on. Last couple minutes I want to spend talking about something that we're going to get into more next Thursday. And this is something called a C string. Not a G string, a C string.
Yeah.
Okay. Anyhow, way back when C was first created, it was really, really powerful. C was created. There were some things that it didn't have. This was also true about Java. And one of the things that C didn't have was a way to handle strings. And what the C language did was what we're basically doing right now, worked with character arrays. Eventually, it becomes C++ because things were added like the string class and how we adopt it. And the same thing happened in Java, because I can remember having students take the high school AP test, and they had to learn the commands for a supplemental package called string, because we didn't have string way back. Remember, I started teaching this stuff in 87, so it's been, or 86, whatever, it's 35 years of it. So what we've been looking at, and we're going to start talking about these things called C strings. And then next week we'll get into functions that deal with them. But as you can see, a C string is a list of characters terminated by the null character. The null character is a /0. Okay, it's one of those escape sequence characters like /n was. I have a note on here that it's the ASCII code for 0. Something you may see somewhere along the line, see that lowercase b with a slash? Well, that goes back to my old COBOL days, Common Business Operating Language for business classes. And we used to have to format and lay out our format. One of the things we used to have to do was put that /b in. So when we're talking about this legacy stuff, this old C string, some things come into play that we didn't have the string class. We have this lowercase b with a slash, and I'm doing a little old school on you. All right. So the C language does not have a string class like C++ does. So we're going to talk about it because some of you get jobs, and part of your job may be to go back and look at old C code, fix it up, modify it, rewrite it, whatever needs to be done. Okay. So it's good to know that this kind of thing exists. Now, whenever I want to work with this character array, and for example, I want to store hi mom, I need to make this array of size at least 7, because I always want to make sure that I can put that null terminator in there. So 1, 2, 3, 4, 5, 6, that /0, the null terminator is going to help me out. So now I'm starting to think that, okay, if that's going to be in there, if somebody said, what's the length of this? Could I go through until I find that null terminator? Did one of my groups do that?
Yes.
Yes, I thought I saw at least one group working with this null terminator. So somebody read ahead, which is great, and they had an idea of what's going on coming into this. Okay, so code listing 10.5, it comes in and it's doing the same kind of thing as before. Here's another old school thing. What's this 80 represent? Why 80? I've seen 80 a couple of times. I'm going back old school. It's been a long time, but I'm pretty sure 80 was one of two things. A punch card, which was one line of code, I'm pretty sure had 80 columns. Somebody said the length of a typewriter. Now, I'm pretty sure it was from the punch card. And the other thing is our old screens, the monitors, the cathode ray tubes were 80 columns by 26 rows. There was no zooming in and zooming out and all of that. So 80 is just one of those old school numbers that comes up once in a while. So if I declare my array of size 80, that means I can store 79 characters in there, leaving one for that null 0. Okay, and a little bit more with this. Chewbacca, while it doesn't equal that, I can go through and print out everything that's going on, print out a character at a time, make it look nice. Again, when I'm working with characters, I remember I may need endlines once in a while, or that /n, that kind of idea. So next Thursday, we're going to start with 10.4, and we're going to look at a whole bunch of functions that are written to go along with the C string class that I can use on my character arrays. But for now, I'd like you to see if, and I'm going to cut you loose on your own to do this one. One more program for you to work on your own is this number 15, character analysis. All right, write a program that reads the contents of a file that will do the following. Uppercase letters, how many? How many lower? And how many digits in the file? Okay. So again, I'm going to open the groups back up. If you want to go work in a group, you only have a couple minutes. You want to leave, that's fine. You want to work on this, it's all good. But this would be good practice for you. Now this says download the blah, blah, blah. You can make up your own test data file. That's not that hard. Go and get Sonnet, whatever that was. Sonnet 18. Question, do we have to submit an algorithm or test data for assignment 8? No. No more algorithms or test data. Hopefully by 9 weeks into the course, you're trained to see the advantages and disadvantages of doing that. You're now on your own, young butterfly. Okay, stopping the recording.